Hi guys, today we are going to be carrying on doing our video memo for past paper 1 of 2019 for the National Senior Certificate. Last lesson we did question 1.1, so today we're going to do question 1.2, which is a simultaneous equation. The first equation is 1 plus y plus x equals 12, which we're going to make y equals x, 12 minus x. Okay, so that's our first equation, equation 1. Okay, so what we're going to do is into the second equation, well, the second equation is xy equals 14 minus 3x. We're going to put in, for y, we're going to put in this 12 minus 3x, because y we know is 12 minus 12 minus x, not 3x. So we put that in, 12 minus x equals 14 minus 3x. We times it out. 12 times x is 12x minus x squared equals 14 minus 3x. I'm going to take the x squared to the right-hand side so that it becomes positive. And then I have 12x. The 12x goes to the other side and becomes minus 12x. So I have 12x minus 15x equals 14. So if you have a silver calculator, you could put this in and you would get your answers, but you wouldn't be able to just put in the answer. Remember, the answer, if you put it into the silver calculator, is going to give you 14 and 1. So what I must do is I first have to do the brackets x minus 14 and x minus 1 so that it looks, so that you get the method marks, because otherwise they're going to know that you just used your calculator and basically cheated. So you do that. But it's not a really difficult one to factorize, because this was a plus 14. Yeah, plus 14. You knew that the signs were the same. So it was either going to be negative and negative or positive and positive. It was negative and negative. And negative 14 minus 2 minus 1 will be negative 15. It couldn't have been 7 and 2 because that would have given you minus 9. And so now you know what x is and you can solve for y. So you simply substitute these x's into the equation 1. So equation 1 was y equals 12 minus, and we're going to put in the 14, and y equals, and it was 12 minus 1, and so you get y equals negative 2, and y equals 11. So that's question 1.2. I'm just going to highlight the final answers in white. Okay, question 1.3. This one. Okay, so this question here, there's no memo. So basically, this is going to be the memo. Yeah, I checked on the government website and I didn't notice a memo hasn't come out yet. And there was actually some controversy with this question because they said it wasn't part of the syllabus. Because it wasn't really a standard question. However, we have done it. This sort of stuff we did do, but it was more like in grade 7, grade 8, where we learned prime factors and how to factorize a number. So let's just do one of those early examples just so that I can show you what I'm talking about, because this is a difficult question that takes a little bit of understanding. Remember, say you were given the number 90 and you were asked to factorize it using the ladder method. Okay, so we would do this. We would say, well, the smallest factor is 2, goes into 9, and then we would have a 45. Then we would say 3 goes into 45 15 times. and then 3 goes into 15 5 times, and then 5 goes into 5 once. So if we were to break 90 up into factors, we would have 2 times 3 squared times 5 times 1. So what this question is asking is, so 1 times 2 times 3 times 4 times ... times 30, where k is a value such as 3 to the k. What we're saying is, how many times does 3 go into this large number here, which is 1 factorial? How many times does it go in, as it is a prime factor? So, well, let's look at 3 to the 0. 3 to the 0 goes, 3 to the 0 is equal to 1, okay? And 3 to the 1 is equal to 3, and 3 to the 2 is equal to 9, etc., etc. And we could go as many times. We want to know how many times could we go up. 3 to the 2 is equal to, 2 to the 3 is equal to 27, and so forth. Now, I want to see, so k could be any of these numbers. So what we have to do is look and see, if we were to do the ladder method, well, we can't really do it because this number is huge. So what we have to do is look at all the factors of 3. So any number which has 3 as a factor. So the first number would be 3, which is 3 to the 1, okay? The second number would be 6, and that's 3 times 2. What I'm going to do is, I'm going to take a little bit of time, and if you already understand what I'm doing, maybe just skip a little bit ahead in the video, because I don't want to bore you. But I'm going to do the 3s. That's not coming out that clearly. I'm going to do the 3s in yellow, so that we can keep track. So we got 3 to the 1, 3. I'm just going to do a bunch here quickly. Okay, the next one would be 9, which is 3 squared. The next one would be 12, which is 3 times 2 squared. And the next one would be 15, which is 3 times 5. 18 is equal to 3 times. That's 3 squared. 3 squared times 2. We're nearly there. 21, 24, 27, and 30. Okay, that's just 3 times 7. 24 is 3 times 2 to the 3. 27 is 3 cubed. And 30 is 3 squared, 3 times 5 times 2. Okay, so now in yellow again, all the 3s. So it's 3 times 7, 3 times 2 to the 3. This is 3 cubed. And 30 is 3. So because these numbers are all timesed out, so I'm going to put them in green so we can see times that I'm talking about the timesing this whole number. Okay, now I've turned those, I found all the factors of 3 in here at the bottom over here, and those would be multiplied together. So if I was to times all the 3s together, I would have 3 to the 1 times 3 to the 2 times 3. So all the ones in yellow are basically being times. So all I need to do now is count how many times I multiplied 3. So I'm going to do that in a different color. We had 1 here, 2, another 2 here, so it became 4, 5, 6, 8, 9, 10, 13, and 14. 4, 12. Just double check that. 24. Yeah. Okay, so altogether you would have 3 to the 14. Therefore, k is equal to 14. Right, so that was my solution. I don't know if anyone's got a better one. If you do, please send it through, put it in the comments below and berate me. But yeah, hopefully that helps you out. And in the next lesson, we will be doing question 2.